Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. This is Easier, Practical Applications of Machine Learning Algorithms in R, and we're now in Unit 4, Lesson 3. And we've been in this chapter looking at classification rules. So in this particular video, we're going to take a look at actually using the one-rule algorithm to develop and test a model. So let's go ahead and move over to RStudio. So you can see that we're getting ready to create our model here. So what we're going to do is in line 10, we'll set our seed again for consistency. And we're going to create an object. Let me go ahead and make this a little bit easier to see here because it's kind of squished up. So here we go. We're going to create an object called males1r. It's just, males to the data set, 1r means one rule. And we're going to use the 1r algorithm, and this is what we're going to do. We want to predict if somebody is married or not. So we're doing classification. Are they married? Yes or no? And we're going to use the following variables here: ethnicity, union, industry, school, experience, occupation, and residency. And all this is coming from the training set data. So I'm going to run lines 4 through 6. And it's fast because this is not a large data set. Now we're going to take a look at the actual algorithm and see what it tells us. So I'm going to give you some little bit of space here so we can see this and appreciate it. So this is line 7. I press Control Enter, and this is the one rule. Now here's how this works out. Let me make this bigger for you because this is the important part, kind of the punchline here. Here's how this works. So if someone has less, let me slow down. The variable that the algorithm chose to classify everything was the experience variable. So how much work experience that an individual male had. So here's how it works. If somebody has less than 7.5 years of experience, they are not married. Else, if they have less than 12.5 years, but probably more than 7.5 years, then they are married. Then, or you could say then they are married. And so then after that, if they have less than 13.5 years, but more than 12.5 years, they're not married. Else, if they have more than 13.5 years, they're married. Now, then at the bottom, it gives you how many are correct. So out of the 2,173 data points, we got 1,386 correct, which is not that great. But here's kind of what's happening. If somebody has less than 7.5 years experience, they're not married, which makes sense. These are young males. They don't have a lot of experience, so it's very hard to support a family. But once they get to 12.5 years or less, so usually somewhere between 7.5 and 12.5, they're married. Which again, if you think about it, a man works for a few years and he gets married. But then something weird happens. Around from anything from 12.5 to 13.5, when it's less than 13.5 but more than 12.5, they're not married anymore. So we could speculate forever, but just using some common sense, it's very common for people to get divorced around this time. And then lastly, if they have more than 13.5 years, they're married again. So either they got married a second time or they were able to survive that rocky in-between phase. Again, we're just speculating, but to give you some insight into what's happening with the data. So let's go ahead and zoom out and get some more insights into the data. So in line 9, we have the summary function that we're going to use on the data, on the model that we just created. Oops, excuse me. And so if you press Control Enter, you get all these descriptive statistics about our data, or about our model. So you can see here the accuracy was 63%, the error was 36%, the kappa was 0.23, which is pretty poor. Mean absolute error, root mean square error, all these things are available. Relative, absolute error, all these different things are available for you. And then down at the bottom, it gives you the confusion matrix. So 956 were predicted and classified as no, 430 were predicted and classified as yes, and then you have your type 1 and type 2 errors on this opposite diagonal here. So the model's not looking that great. We already have indications that it's not a very strong predictor, but we're just practicing here for fun. Now, in line 12, we're going to take the model that we just created and we're going to predict using the new data from the testing set. So that's what we're going to do here in lines 12. And now we're going to make the confusion matrix to get an idea of what it looks like. And you can see here that we still kind of have the same amount of problems here. We got 520 no's right, 287 yeses right, but then we still have a lot of type 1 and type 2 errors here, indicating that there's a problem. Now, to determine the actual accuracy of the model, in line 15 we have the code there, so we're going to compare the times where the test model and the testing set are the same. It'll give you an average here. And so you can see here 62%, basically 61.7 to be strict. And that's a little bit below our model development parts, which was 63.7. But you know, the model generalizes even if the model is poor. It's kind of what we're learning here. So this is how you use the one rule algorithm. Very practical, very fast. And if we wanted to improve the model, we might include other variables or maybe remove variables. There are different ways things that we can do to try to adjust what's happening here, but that's not the purpose of the video. So I hope that this made sense and you were able to kind of follow along what we did today. So my name is Darren Thomas. I am the Director of Educational Research Techniques. This is easier, practical applications of machine learning algorithms in R. Take care.